Hey everyone, welcome back. This is going to be 9.4b lesson where we're going to continue talking about factoring, but just with special cases that look a little different than normal. So our essential question, how do I solve equations for the roots? Okay, so we've already kind of done some of that. How do I factor all types of general equations? So we're going to look at more or weird different types of general equations, and then how is solving for x and finding the x-intercept similar? Hint, they're the exact same. Okay, example A. Factor the following trinomial, then determine what x must be. So when you see something like this, 1, always make sure that your equation equals 0. That is priority number 1. Then it's what we did in 9.4a. We go through and ask ourselves the two questions, remembering that the two questions are what adds to 2, or b, and what multiplies to c, which in this case is -3. So we're looking for two numbers that have to add to 2, and those same numbers have to multiply to -3. Okay, and remember to do that, we break down -3, so that's 1 and -3, or -1 and 3. One of those has to equal 2 when we add them, and oh look, it would be -1 plus 3 and -1 plus 3. So what does that mean? It means that we have x minus 1 in parentheses, and we have x plus 3 in parentheses, and that has to equal 0. Then it says determine what x must be. Okay, this is another way to say what are the roots. Okay, so what number minus 1 gets me 0? So x minus 1 equals 0, so x has to equal 1, aka root is 1, and then we also have to do the same thing over here. So x plus 3 equals 0, minus the 3, and x equals -3. So those are the roots. Those are the values that x has to be in order for our equation to equal 0. All right, let's continue with b. So same thing. What adds to 11? What multiplies to 18? So break down 18. So 1 and 18, 2 and 9, 3 and 6, and we can go on, but we know that 2 and 9 add up to 11. And multiply to 18, so then that becomes x plus 2 because it's positive 2, x plus 9 because it's positive 9, and that equals 0. Then we just set each parentheses equal to 0 and solve. So x plus 2 equals 0, x plus 9 equals 0, minus the 2 over and get -2, minus the 9 over and get -9. Okay. What we just did there is called the zero product property, or ZPP for short. What does it mean? It simply means that we are finding the x value, okay, when both parentheses equal 0. So both parentheses equal 0. That's all the zero product property means. Okay, product, remembering multiplying. So we are looking for two numbers that multiply to 0. Okay, not really super important, just as long as you remember the steps. Next question, when you find an x-intercept or a root, what is the y-coordinate equal to? Okay, so remember when we were looking at our roots, it was always some number, comma, some other number. Well, what was that y-coordinate? Well, that y-coordinate was always 0. So it was always y equals 0. Hence why we call it the zero product property. Okay. So if we had equations like x squared plus 2x minus 3 and x squared plus 11x plus 18, those are the ones from the previous example. What are the roots? Well, we already found them, so we'll just scroll up. So the roots were 1 and -3 for this first one. And then for b, if we scroll back up, they were -2 and -9. So I wrote it as x equals. If we wanted to write it as a point, okay, remembering that the root occurs when y is 0, so it would be -1, 0, and -3, 0, and -2, 0, and -9, 0. Okay, so you could write it either way, x equals or with the point value. And that was a positive 1, sorry, my mistake. So positive 1. So that concludes our front side. Let's go ahead and, oh, that was my dog Ava. Thanks for that. And we will flip it over to the back side. All right, so for example B here, we're just going to practice using the zero product property and solve for the following. So what does that mean? It means we want both parentheses equal to 0. So x plus 4 equals 0, and we're going to solve that. So minus the 4 from both sides and get x equals -4. And we do the same thing for the other parentheses. So x plus 3.5 equals 0, minus the 3.5, and x equals -3.5. All right. For b, notice how they put a number in front. So we have an a. That does not affect the roots at all. So we are only looking at things inside the parentheses. So that 2 does not even affect our answer. We can just still do what's inside parentheses number 1. So that's x minus 2, add the 2, and x equals 2. So that would be a root. And then we would do the same thing for the second parentheses, x minus 6, set that equal to 0, add the 6, and x equals 6. So that 2 on the outside doesn't affect anything. Moving on to C. For C, take the first parentheses, set that equal to 0. So x plus 3 equals 0 minus the 3. So x equals -3. Take the second parentheses. So notice that we have a 2 inside with x. So we're just still writing it out. But notice that this is going to have one more additional step. So we're going to add the 1 first, just like we did a long time ago, solving for these t-chart method, and then divide by 2. And then my other one is going to be x equals 1/2, or x equals 0.5. Okay. Same thing for D. Take what's inside the first parentheses, set it equal to 0. Now we're going to like t-chart or balance method and do 3x equals 2, divide by 3, and I get x equals 2/3 or 0.6 repeating. And then x plus 7 equals 0, minus the 7, and x equals -7. Okay, so you're just taking what is inside parentheses 1, set it equal to 0, solve. Take the same thing for number 2, set it equal to 0, and solve. For example C, we're going to put it all together now. So we're in general form, we need to go to factored form, and then we need to find the roots. So we're going to ask the question, what adds to -7 and multiplies to 10? So adds to -7, multiplies to 10. So break down 10. So 10 can be 1 and 10, 2 and 5. And then notice again that we want a -7, but right now those answers would be positive. So I need to make both of them negative. And then I would find that -2 plus -5 is -7. And -2 times -5 is positive 10. So then my equation would be x minus 2, x minus 5, and then that equals 0. Okay, and that's the first step. So go through your two questions, find your numbers, write it in your parentheses. Second step, take each parenthesis separate and set it equal to 0. And then your last step is solve for x. So add 2 over, x equals 2. Add 5 over, x equals 5. Okay, let's try b. So what adds to 6 multiplies to 16? Break down negative 16. So negative 1, 16. Negative 2, and 8. Once you found it, you can stop. So I know that negative 2 plus 8 is positive 6. So I don't need to continue on. But if you want to be safe, you can continue listing out all the factors of negative 16. Okay, so that was step 1. Now, step 2, write it out. So x minus 2, x plus 8 equals 0. And now finish solving. So x minus 2 equals 0, x plus 8 equals 0, x equals 2, x equals negative 8. Okay, so there you factored and you found the roots for everything. All right, so now we're going to look at example D here. This is where we get into the weird cases, the different cases. So it says factor the following and solve. ... What value is b? So if I look at these, and the reason why they're different is because I don't have a b value. Okay, so that means that b has to equal 0. So that means when I'm asking my two questions that these two numbers have to add to 0, and they still have to multiply to negative 49. Okay, so let's think about this. How can I get two numbers that add to 0? Well, that means they have to be the same value, but with opposite signs. So I'm looking for two numbers that are the exact same and multiply to 49. So when I'm looking at negative 49 and I'm breaking it down, I am looking for numbers that are the exact same, like 7 and negative 7. So then I can write it out as x plus 7 and x minus 7. And then when I solve, I get x plus 7 equals 0, x minus 7 equals 0, and x equals negative 7, and x equals positive 7. Okay, now let's try b. So b, same thing. My b value is 0, so I'm looking for two numbers that add to 0, and they also have to multiply to negative 36. Okay, so I break down negative 36, and I'm looking for two numbers that are the exact same with opposite signs that multiply to 36. Well, that turns out to be negative 6 and 6. So then that's going to be x plus 6, x minus 6, set each one equal to 0, and solve. So x equals negative 6, and x equals positive 6. All right, C, same thing. What two numbers add to 0 and multiply to negative 16? So again, I'm looking for two numbers that add to 0 and multiply to negative 16, and I will find that that will be 4 and negative 4. So that'll be x plus 4, x minus 4, set each one equal to 0, and solve. So x equals 4, and x equals negative 4. Okay, the reason why these are special or different is because 49, 36, 16 are what we call perfect squares. Okay, which just means that you're going to get the same answer with opposite signs. So it would be 7 and negative 7, 6 and negative 6, 4 and negative 4. So whenever your b value is 0, look for these numbers. All right, that concludes our 9.4b notes. Look for the 9.4b practice to try out your skills. Have a great day.